Imagine a place where the very fabric of space-time is torn apart. A place where gravity is so strong that not even light can escape. These are black holes, the most enigmatic objects in the universe. Black holes are the remnants of collapsed stars, moving and warping space-time around them. Invisible to the naked eye, their presence is detected by their gravitational influence. They challenge our understanding of the universe, pushing the boundaries of physics. They force us to confront our knowledge limits. Within them lies the potential to unlock the universe's biggest secrets. Could our universe be contained within a black hole? The idea may seem absurd, even impossible. But the universe is far stranger than we could have ever imagined. The journey to understand these objects is a journey to the edge of human comprehension. It will challenge our preconceptions and confront the deepest mysteries of existence. What happens when gravity becomes the ultimate master of the universe? At the heart of every black hole lies a boundary known as the event horizon. This is the point of no return, beyond which gravity's pull is so strong that nothing, not even light, can escape. Cross the event horizon and you are lost forever to the universe you once knew. Actual time itself seems to warp and distort near the event horizon. From an outside observer's perspective, an object falling into a black hole would appear to slow down as it approaches the event horizon, eventually freezing in time. The object itself, however, would experience no such slowing of time. It would simply fall through the event horizon, unaware of its impending doom. This discrepancy in the perception of time is one of the many strange and counterintuitive consequences of Einstein's theory of general relativity, which predicts the existence of black holes. But don't get it wrong. The event horizon is not a physical barrier, or something you can even see or touch. It is simply a region of space-time where gravity is so strong that our rules of physics break down because they just can't keep up. We can only imagine what horrors await those who are unfortunate enough to cross this cosmic threshold. At the center of a black hole is where everything seems to break down. Over there lies a point of infinite density, the singularity. Here the laws of physics cease to exist. The singularity is where our understanding breaks down. It tears apart space-time. In other words, making space and time completely meaningless. Singularities are predicted by general relativity. Yet, they suggest our theories are incomplete. Quantum mechanics suggests space-time itself is quantized, which prevents the idea of true singularities. But quantum gravity still remains a mystery waiting to be uncovered. Until then, the singularity remains an enigma. The mind-boggling nature of black holes has led some physicists to propose a radical idea. What if our entire universe is inside a black hole? This is the central tenet of black hole cosmology. The theory also suggests that our universe is just one of many, perhaps even an infinite number, of universes contained within black holes. Each of these universes could have its own unique set of physical laws and constants. The idea may seem outlandish, but it is not entirely without merit. Take the expansion of our universe, for example. As observed in the redshift of distant galaxies, this occurrence is consistent with the behavior of matter falling into a black hole. Furthermore, the cosmic microwave background radiation, the faint afterglow of the Big Bang, could potentially contain subtle imprints of the universe that existed before ours. While still highly speculative, black hole cosmology offers a remarkable glimpse into a much larger and more complex reality than we have ever imagined. It suggests that our observable universe as vast as it is, may be just one small part of a much grander cosmic structure. Let's go all the way back to the Big Bang and try to find any hidden clues there. The Big Bang theory describes a universe that began from an extremely hot, dense state, which has been expanding ever since. But what if the Big Bang itself was triggered by a black hole? I mean, how crazy would that be? Right? Believe it or not, some physicists believe the singularity at the beginning of our universe could be from a black hole in a higher dimension. This idea links the birth of our universe to the death of a star in a higher dimension. At this point, while I'm editing this video for you, my friends, I just had to take a deep breath. Now that we have established that there are actual trusted minds thinking about such a gasp-worthy scenario, let's continue our exploration. Gravity. Despite being the weakest of the four fundamental forces, our buddy here might hold the key to understanding the true nature of black holes and their role in the universe. Einstein's theory of general relativity describes gravity not as a force, but as a curvature of space-time caused by the presence of mass and energy. Black holes, with their immense gravitational pull, represent the most extreme manifestation of this curvature. But what if gravity is even weirder than we thought? Some theories suggest that gravity might be an emergent phenomenon arising from the interactions of more fundamental entities, much like how temperature emerges from the movement of molecules. If what was just said is true, this could have profound implications for our understanding of black holes. It could mean that the singularity at the heart of a black hole is not a true singularity at all, but rather a breakdown of our classical understanding of the space-time fabric. Further exploration of these ideas could lead to a revolution in our understanding of gravity and its role in shaping the cosmos. It could even unlock new avenues of research into the nature of dark matter and dark energy, the mysterious invisible stuff that make up the majority of the universe's mass and energy budget. But wait, there is actually more to this. To truly understand black holes, we should join general relativity with the other pillar of modern physics, quantum mechanics. This unification is the holy grail of modern physics, and it is essential for understanding what happens at the singularity. One promising approach is loop quantum gravity. To briefly describe it, loop quantum gravity suggests that space-time itself is quantized, meaning it is not smooth and continuous, but rather made up of discrete units, like pixels on a computer screen. This granularity of space-time could prevent the formation of true singularities, resolving the dilemma of the infinite density. Another promising avenue is string theory, which claims that the fundamental building blocks of the universe are not point-like particles, but rather tiny vibrating strings of energy. String theory also suggests the existence of extra-spatial dimensions beyond the three we experience, which could play a role in the formation and behavior of black holes. By exploring all these theories, we may finally be able to peer beyond the veil of the event horizon and unravel the secrets of these enigmatic objects. I truly hope for that, because this is just too much exploration to do, in my opinion. The study of black holes is one very stressful confrontation with the limits of our knowledge and imagination. It forces us to confront the vastness of the universe and the humbling realization that we are only the smallest part of something much grander. The idea that our universe might exist within a black hole is terrifying, exhilarating, just shell-shockingly amazing. It challenges our perception of reality and forces us to question our place in the cosmic order. But this is the essence of scientific exploration. To venture beyond the familiar, to embrace the unknown, and to continuously refine our understanding of the universe and our place within it. And perhaps, just perhaps, hidden within the depths of a black hole lies the answer to the ultimate question. Where did it all begin? I know for a fact there are a ton more theories to talk about to try to answer this question. But let me leave that to you guys in the comment section below. Write as much as you can. Don't forget to like and share this video. Subscribe. And hit the bell icon to get more brain-teasing questions like this. Trust me, you don't want to miss what is coming next. As always, what are you waiting for? Say it to yourself. Thank you for watching.